mean? What does it mean for something to be a trig ratio? What is that?
Does it like give you the sides?
What sides?
Like it depends.
It depends. Yeah, it totally depends. So what does it depend on? Like sine gives you what ratio?
Opposite or hypotenuse.
Good, yeah. So sine is opposite over hypotenuse. And again, we write that as SOHCAHTOA is our way to remember what the relationships are. So again, the trig ratios, sine, cosine, and tangent, are just ratios so that the sine of any angle, so in this case we're talking about angle B, the sine, which again is just the ratio, the sine of angle B, whatever B is going to be equal to the ratio between the cosine of adjacent, which would be what in this case? 7, over the hypotenuse, which would be what? Good. So the cosine of B would be equal to 7 over 25, which if you guys did that on your calculator, what is 7 over 25 as a decimal? 0.28. So 0.28. So cosine of B is equal to 0.28. So we're going to talk a little bit about what to do then in terms of figuring out the actual angle. But for now, we're just reviewing what we talked about yesterday. All right, how do you do number 7? Because I only gave you a little bit of information. And again, you can plug it into your calculator and get a decimal, but you need to write it as a simplified fraction. So how would you do this? What? Okay. But if it's not something that's easy to convert from a decimal to a fraction, what do you have to do, Bianca? Since it's sine of 30, you know we're talking about the parent triangle of 30, 60, 90. So again, it's not optional. You have to memorize these. Okay? So 30, 60, 90. This one is what? Across from the 30 is S. Across from the 60 is S root 3. And up here on the hypotenuse is 2S. Okay, so then if we're looking at sine 30, sine is what? Opposite over hypotenuse. So what's opposite the 30? S. And what's the hypotenuse? 2S. What happens with our S's? Cancel out. So then what are you left with? 1 over 2. Okay, the 2 is in the denominator. You need a placeholder in the numerator, so it's just 1. S over S, everything divided by itself gives you 1. Okay, and then Melanie asked, how do we do this one? This one is 2 parts because it's asking for each length. So what I did is I just labeled this one X and this one Y. You just have to do 2 problems. So let's start with the X problem. I have this angle, that's 41. What is the relationship between 41 and this side right here? This is what? Opposite. And then this is the what? Hypotenuse. So which relationship compares opposite to hypotenuse? Sine. So I'm going to do sine 41 equals, what's the opposite? 12.2 over the hypotenuse, which is X. Since I want to do a proportion, I'm going to write this over 1. Okay, so then when I cross multiply, what do I do? Sine 41 times X equals 12.2 times 1, which is just 12.2. Okay, how would I finish this? Divide by sine 41. And you end up with X equals, and you do that on your calculator, I think it's 18. 18.59. 18.6. Okay, 18.6. Again, that's approximate, so we can put like a wiggly equal sign because you don't want to write all this stuff. All right, so again, this is the proportion that we're using because we had the opposite and we were looking for the hypotenuse. But now, if I want to figure out y, how would I do that? What do I have? I have the 41. I still have the opposite, but now what am I looking for? The adjacent. So what trig ratio would I have to use? The T1? Tangent. Why tangent? Opposite over adjacent. So we're going to still use angle 41, but this time we're going to do tan 41 equals 12.2, 12.2 over y. All right, so again, we write that over 1, and we do the exact same thing. So you do cross multiply to get tan 41 times y equals 12.2, and we finish it by dividing by tan 41, which if you do that on your calculator, you end up with 14.03. So I'm definitely not saying this stuff is easy, because I don't think that it is. But once you start practicing with the trig ratios, it gets a little bit easier, because you start to see what you're missing and what you're looking for. Okay, and again, all trig ratios means is the tangent of this angle is equal to opposite over adjacent. The sine of this angle is equal to opposite over hypotenuse, because sine is always opposite over hypotenuse, cosine is always adjacent over hypotenuse, and tangent is always opposite over adjacent. Okay, so those ratios won't change. Because sine and cosine and tangent are all different ratios. So we use the same angle, but we're doing different sides. Because here we're looking for this side, this was x. Here we were looking for x, so it was a different side. And here we're looking for y. But that's a good question, because it looks like the exact same angles. But think of sine, cosine, and tangent like different operators. So think of it like one's like division, one's like multiplication. You're doing different things, okay? Or they're different numbers. It's like, you know how pi always stands for 3.14? Sine, cosine, and tangent kind of always stand for something. Okay, they're not the same as each other. So when you do them to the same numbers, you're going to get something different. Okay, so how can we use that to determine angles? Because so far all we've done is determining sides. So take a look at this one. This says given cosine angle A is equal to 0.6, which angle, 1 or 2, would have to be A? So cosine of A is equal to 0.6. So I need to figure out which angle is A. How do you think we should start this? Cosine is c, right? So adjacent over hypotenuse. What are the two angles that I have? 1 and 2. We don't ever really do 90, all right, because there's no, like you can't have an opposite because it would already be the hypotenuse. So you don't do the 90, so we just have 1 and 2. Well, what's the cosine of 1? Is adjacent over 6, whereas cosine of 2 is what? 4.8 over 6. Which one of those gives you 0.6? How could you figure that out? Yeah, just do it on your calculator. 3.6 divided by 6 and 4.8 divided by 6. And which one's going to give you 0.6? 3.6 over 6 gives you 0.6. So then angle 1 is angle A. How? Because what's 3.6 divided by 6? And then what's 4.8 divided by 6? So then if cosine of A is 0.6, which one of these is A? Angle 1. Because the cosine of angle 2 was 0.8. Try it out with both of them. Just 2. You don't have to do this one, because we don't do the 90 degree. Okay. So given sine of angle A is 0.8, determine which one is angle A. So try this one. Again, remember sine is what? So this is op over hypotenuse. Okay, so take a look at angle 1, take a look at angle 2, and figure out which sine of those would give you 0.8. You should still have an answer. I mean, it might be the same as what we just did, but you should still have an answer. So what's the sine of angle 1? 4.8 over 6. And what's the sine of angle 2? All right, so which one gave you 0.8? So which one is angle, wait. Angle 1. Okay, so angle 1. So this one should have been angle A. All right, so you try them both and figure out which one gives you 0.8. This one gives you 0.8 because this one gave you 0.6. Okay, so yesterday we talked about how to use the trig ratios to find side lengths, but today we're going to talk about how to use the inverse of these ratios to find angle measures. So everyone look at your calculator. See the sine, tan, or sine, cosine, tangent button? What's above those? Like what's the shift of those? Not the button above. Sin -1, cos -1, tan -1. What does that mean, -1? Yeah, it's not squaring it. It's just the inverse of it. So what does inverse mean? Like backwards, right? Like the inverse of multiplication is division. The inverse of squaring is square rooting. Exactly. So the inverse of sine is sine -1. The inverse of cosine is cosine -1. And the inverse of tan is tan -1. And here's when we're going to use this. Okay? So let's say, for example, that you had these. So go ahead and give me the sine of the inverse sine of 45. So try that on your calculator. How do you get to those buttons? Hit second. So hit second sine and then 0.45. You with us? What'd you get? 26.74. And then what would inverse tan of 3.2 be? 72.65. These are approximate, right? Okay, so 72.65. So we're going to use these when we're looking for angle measures. All right, we're going to use these when we're looking for angle measures. So here is how. Okay, so take a look at this. We're going to put together everything we just talked about, and we're going to find these angle measures. So let's take a look at this triangle. It says, I want to solve this right triangle. What it means, what anything means when it says solve a right triangle, is basically just figure out everything you're missing. So in this case, we already know AB and BC, so all we're missing on side lengths is AC. We know angle B is 90, so we're just missing angle A and C. So there's 3 pieces of information we need to find. There's really only 2 things we need to find with the angles, because once we find one, how can you find the other? Just subtract from 180, okay? So let's start by finding the measure of angle A. So here's how we're going to do that. All right, what 2 pieces of information do I have? I have the adjacent and the opposite, and I'm looking for this angle, right? So how do you think I could set that problem up? Tan what, though?
Do you just like subtract them or something?
Do you know what it is? Tan of what this angle is? No? No? So I'm going to say tan x, because I don't know what that angle is, equals what? I don't know what this is. I don't know what this angle is. So let's call it A, because it's actually labeled A. So let's do tan of A, because I don't know what A is.
I mean, in general,
It's opposite over adjacent for tan. SOHCAHTOA, OA. So opposite over adjacent. So that means tan A would be equal to what? 5 over 7.5. All right, and I want to figure out A, right? So I need to get rid of the tan. And how do I get rid of something in math? Well, if it's multiplication, I divide. If it's adding, you subtract. If it's tanning, what's the opposite? Not sin, tan -1. So the inverse of tan is tan -1. So to get rid of this, we have to do tan -1 of this. And that would leave us with just A. So if I'm looking for this angle A, I do the inverse tan of whatever I have. 34, what? 34.6. Hang on. That's not it? I just turned it off. 5 over 7.5. Okay, 33.7. Yes, 33.7. So A equals 33.7. So then that's your angle A. So angle A is 33.7. Okay, now what could we do to get C? We could just subtract it, but I want to try this again so you guys can practice this one more time. So let's say I'm looking for angle C. So I'm going to get rid of this. If I'm talking angle C, what do I have compared to C? Opposite and adjacent. So I'm still going to use what? Tan. So I'm still doing tan C, but in this case, what's opposite? 7.5. So that goes on top over 5. And again, how do I get rid of tan? Tan, negative 1. So C would equal tan negative 1 of what? 7.5 over 5. 56.3. Which makes sense because these two should add up to what? 90, because then you add another 90. Okay? So C equals 56.3. Are these inches or degrees? These are degrees. All right, so what's the opposite of tan? Tan, negative 1. What's the opposite of sine? Negative 1. What's the opposite of cosine? Cosine, negative 1. Okay, so then last but not least, because we did A, so this was A. Now we did C, we already did this one. So now how will we find AC? So I know this is 33.7, and this was 56.3. So how would I find this right here? Sine or cosine of any of the angles. I said, which one don't we use? 90. So pick another one. Daisy, which one do you want to use? You want to use this one, 33.7? Okay, so I know opposite or adjacent, but I need the hypotenuse. So I can either use what? Cosine or... I can't use tan because tan I already have both of. So sine or cosine. Kiara, which one do you want to use, sine or cosine? Cosine? Okay, so we're going to do cosine of 33.7 equals, so what's adjacent to 33.7? 7.5. And then I don't know the hypotenuse, so that's x. I put this over what? 1. All right, now what do I do? Cross multiply. So I get cosine 33.7 times x equals 7.5. How do I finish? Divide by cos 33.7.
So you can't use the TOA because it's a...
No, because you already have those two. You're not looking for either of those two. So if you used TOA, you would have a fully filled in, you would not have a variable.
So you need to
Yeah, because that's the one you're looking for. Yep. Because you need one that has a hypotenuse because that's what you're looking for. So I need cosine 7.5 divided by cosine 33.7.
Wait, with that one you use a negative?
Nope. Only when you're looking for angles. When it's like cosine of a variable. Because that's when you want to get rid of cosine. But here we already know cosine 33.7. So we were looking for angle A and angle C. That's when you use inverse. If you're looking for side lengths, you don't need inverse. All right, so what's 7.5 divided by cosine 33.7? Say that again. 0.01. Thanks, Charlize. 9.01. Okay, that's a lot, I think, anyway. There's a lot of stuff here. Yep, 9.01. So that means this one is equal to 9.01. All right, is that degrees? No, that's like inches or centimeters or whatever, okay? So there is a lot of stuff here, and it's not easy at all. But the only thing that makes it easier is if you practice it, okay? Because honestly, it's a totally new thing that you've probably never seen before, which is unlike most of what we've done. Most of what we've done is probably related to things that you've seen before. Cosine, sine, and tangent are not really. All right, so go try to do these 3, which is really 9. No, you can do them at your boards. What?